Okay, so my name is Baral, and today we'll be solving Cambridge IGCSE Mathematics 0580 P2 Chapter 7 Graphs, and it will be a continuation of the previous video, right? So before starting, I have to make an announcement that please do like, share, and subscribe our channel. So let's start with question number 16. We have the diagram shows the speed time graph for the first 40 seconds of a cycle ride. This is the graph. Find the acceleration between 20 and 40 seconds. So this acceleration is required, right? So we have 40 and 4, and here we have 20 and 2, right? So this would be 4 minus 2 and 40 minus 20. So we have 22 over 20. This would be 1 over 10 or 0.1. Now we require find the distance traveled. So basically acceleration is how we can calculate the acceleration. We can calculate the acceleration by taking the gradient of speed time graph. Please do make sure that you are being given a speed time graph, and the gradient of speed time graphs gives us the acceleration. For the total distance traveled, we can calculate the area under the graph, area under the line. Sorry. So we can break it down, or let's just take these two trapezium. This is the first one, and this is the second one, right? So we have height of 2 here, and the parallel sides are, this is 10 and this is 20. This would be 10 plus 20 is equals to 30. This would be cancelled out. Then we'll be adding the area of second trapezium, which has a height of 20, and the parallel sides are 2 and 4. This would be 6, right? So we have here 60. So altogether we have 90. Our answer is 90, right? Moving on to question number 17. We are given with this graph. The diagram shows the speed time graph. Again, we are given with the speed time graph for the final 40 seconds of a car journey. At the start of the 40 seconds, the speed is v meters per second, right? Find the acceleration of the car during the first 24 seconds. It requires the acceleration during the first 24 seconds, right? So here we have 0 and v, and here we have 24 sorry, and v plus 10, right? So let's take the gradient for the acceleration, right? So this would be v plus 10 minus v and 24 minus 0. So this would be 10 over 24, and this can be cancelled out. So this would be 5 over 12. You can simply write 5 over 12, or you can convert it in 0.417. In decimals, this will be 0.417. And part B, we are required to calculate the total distance traveled during the first 40 seconds. Oh, the distance traveled is given as 1.24 kilometers. Find the value of v. So it is basically 1.24 kilometers, right? So first of all, we need to calculate this into meters, and as we all know, 1 kilometer is equals to 1000 meters. So 1.24 kilometers would be 1.24 multiplied by 1000. So this would be 1240. All right. So this is the total distance traveled, right? So we have two things here. We have this trapezium and we have this triangle, right? So let's just break this down. This is area of trapezium plus area of triangle, right? So area of trapezium, we have 1 over 2, and for the we have area of triangle as This would be the base. 40 minus 24 is 16, and this is the height, so this would be v plus 10. This is equals to 1240. This would be cancelled out. And for the area of trapezium, we have height as 24, and we have the sum of parallel sides as v. This is v, and this is v plus 10. Right? So this would be again cancelled out, right? So taking 12 as common and dividing it there, we get our answer as, do we get something, or we are taking 12 as common from both, right? So this would be 12, and here will be left with, here we will be left with 2v plus 10 plus v plus 10, right? So this is 1240. 1240 would be divided by 12. Just open up the calculator. 1240 divided by 12 is 103.33. Or did we make some mistake over here? We are given with 24. Let's just break this down a little bit. So this is 2v plus 10 multiplied by 12, and we have here 12v plus 120 equals to 1240, and we are given with 24v plus 120 plus 12v plus 120. So we have this as 240 over here, and this is 1240. This would be subtracted, and here we'll have 36v. So v would be 1000 over 36. This is 27.78. I think we have made some mistake over here. Let's just see this again. Let's just go through this question again. Okay, so the total distance traveled during the 40 seconds is 1.24 kilometers, right? So we need to calculate the area, total area. So that would be area of trapezium and area of triangle. Area of this 1.24 kilometers is basically 1240 meters. This would remain the same, right? So this would be area of triangle and area of trapezium. Right? So area of triangle is 1 over 2. We are given with the base as 16. And we are given with this as v plus 10, right? So this is v plus 10. Okay, I think I found a mistake. And we have the area of trapezium as we have the height of 24, and we have parallel sides. This is v, and this is v plus 10, right? So this is v plus 10, right? So we have this, and this is equals to 1240, right? And when we solve this, we get something like this: 8v plus 80. This would be 2v plus 10. 12 multiplied by 2 is 24v, and this is 12, and this would be 120. 12 into 10, right? So this would be 200, and 200 would be subtracted, so we'll be left with 1040, and 8v plus 24v would be 32v. 1040 divided by 32 is our v. I hope we get our answer. 1040 divided by 32. Yes, we do have our answer. So this is 32.5. Alright, we made a mistake over here. Okay, so moving on, we have question number 18, where a car starts from rest and accelerates at a rate of 3 meters per second square for 4 seconds. The car then travels at a constant speed for 10 seconds. We are given with the acceleration of 3 meters per second square, right? So first of all, we need to find the value of v. For acceleration, we are given with the final velocity subtracted, initial velocity subtracted from the final velocity, and the total time is comes in the denominator, right? So it is basically the rate of change of velocity, right? So the final velocity is v. We have initial as 0, we have total time as 4, and we have the acceleration as 3, right? This would be multiplied, we have our v as 12, right? Now we need to calculate the total distance. For the total distance, we need to calculate the area, right? So area will be a trapezium. We know the area of trapezium, 1 over 2. This is the height, which is 12, and this is the base. These are the two sides, which are the sum of, which will be taken as sum, right? So we have 14 plus this is 10. We cancel this out. We get 24 multiplied by 6, which will be 144, right? Moving on to question number 19, we have on the axis sketch the graph of these functions, right? So when x equals to 1, we have y as 2. When x equals to 2, we have y as 1, right? And when x is equals to 0, we have y as infinity, right? Um, if x is negative 1, we have y as negative 2, right? So when as x approaches 0, we have an asymptote, right? And if we have y as 0, x approaches infinity, right? So we have a graph something like this and something like this, right? In part B, we have y is equals to 2 power minus x. So let's just plug it in. We have x as, if we have x as 1, this would be 2 powered minus 1, which is equals to 1 over 2. If we have x as negative 1, we have y as 2, right? So as the value of x decreases, the value of y increases, right? So this would be something, if we have x as 0, we have y as 1, right? Let's just suppose this is 1. And as x approaches negative values, the y value approaches to infinity. So this would be something like this, right? It's a rough sketch, right? So we have, next we have 20. A car starts its journey by accelerating from rest at constant rate of 0.7 meters per second. This is, I guess, already drawn for 20 seconds before reaching a constant speed of 14 meters per second. It then travels at 14 meters per second for a distance of 210 meters. Right? 210 meters is, it has traveled for 14 meters per second. So let's just calculate how much time does it take. So we have 210 as our distance and we have 14 as our speed. So our time would be 7 threes are 7 twos are, right? This would be 15. So for 15 seconds, it will move for at 14 meters per second, right? So what on the grid complete the speed time graph, right? So we have 20 plus 15 would be 35. So this would be something like this. Here, this we have 35 over here, right? So we have actually drawn the graph, right? Okay, moving on. We have question number 21 given us. This diagram shows the speed time graph for 24 seconds of a car journey, the deceleration of the car in the final 8 seconds. So we have this as 16 and 12. We have this as 24 and 0, right? So it is 12 minus 0 and 16 minus 24. So this would be 12 over 8. Since it's a deceleration, we'll ignore the negative sign. So this would be 3 over 2, which will be 1.5, right? The total distance traveled during the 24 seconds. For distance traveled, we need to calculate the area under the line, right? So we'll be calculating the area of trapezium, which is 1 over 2, our height, and then height will be multiplied. Our height is 12. The perpendicular length or distance between the two parallel sides, right? These are the two parallel sides. And the sum of two parallel lengths, right? This is 16 and this is 24. So we have 16 plus 24, right? So this would be 40 and this would be cancelled out to get 20. 20 multiplied by 12 is 240, right? Moving on to question number 22. We have Annette cycles the distance of 70 kilometers from Midvale to Newtown. Leaving Midvale, she cycles for 1 hour 30 minutes at a constant speed of 20 kilometers per hour and then stops for 30 minutes. She then continues the journey at Newtown at a constant speed of 16 kilometers per hour, right? So at 20 kilometers per hour, constant speed, it travels for 70 kilometers, right? So um, for how many, let's just calculate for how many hours it will travel. We have, and it cycles a distance from Midvale to Newtown. Leaving Midvale, this like she cycles for 1 hour 30 minutes, right? So this would be 1 hour 30 minutes at a constant speed of 20 kilometers per hour, right? So 1.5 multiplied by 20 to get our total, to get the distance it has traveled. So this would be, I guess, 30. So in 1.5 hours, it has traveled 30 kilometers per hour. So this is it. Let's just draw this line. All right. Then stops for 30 minutes. 30 minutes means it stops still. 2. Then she continues the journey to Newtown at a constant speed of 16 kilometers per hour. We are left with 40 kilometers, right? And it travels at a speed of 16 kilometers per hour. So this would be 40 divided by 16 to get our time. This would be 40 divided by 16 would be 2.5. Another 2.5 hours. This would be 4.5 hours and 70 right here. Right? So we have this. Sorry. And this is the final line. So this is our final graph. Alright. Let's just remove this scale. On the grid, draw the distance time graph already drawn. Calculate the average speed for the whole journey. Right? So it has traveled for 70 kilometers. And the total time Midvale took was 4.5 hours. So let's just calculate it. So this would be 70 70 um, divided by 4 point. Yes, this is 15.55 or something, right? This is 15.55. Average speed is basically calculated by using the formula of total distance it has traveled and upon total time taken, right? So this is 15.55. Moving on, we have question number 23. Abdul draws this speed time graph of a journey. The graph has four sections A, B, C, and D. Complete this statement about the speed time graph, right? Section D cannot be correct. Section, yes, section D cannot be correct because speed cannot go in this direction, right? So section D is incorrect. Section dash shows constant speed. This is the constant speed because the speed isn't changing. Section dash shows deceleration. So this is basically deceleration. Section A shows acceleration of dash meters per second. We have to calculate the acceleration over here. So speed has changed to 10 and it has taken 30 seconds. So this would be 1 over 3 or 0.33. Let's just write it 1 over 3. The distance traveled in the first 30 seconds of a journey is distance traveled for the first 30 seconds. So we need to calculate the area of triangle, which is given as 1 over 2 multiplied by 30 and multiplied by 10. So this would be 150, right? So this is 150. Moving on, we have question number 24. Given as the diagram shows the speed time graph of the first 15 seconds of a car journey. Find the acceleration of the car during the first 5 seconds. For the acceleration, we need to calculate the gradient. Here we have it has moved in y direction to 14 and in x direction it has moved to 5. This would be 14 over 5 and this would be 2.8 in decimals, or you can simply write this down as well. So here we need to find the distance traveled. For distance traveled, we need the area under the line, right? And area under the line is basically a trapezium. So we'll be using the area of trapezium formula. We have our height as 14 and we have our parallel sum of parallel sides as 15 and this is 10. So this would be 7. 25 multiplied by 7 is 175, I guess. Yes. Moving on, we have question number 25. The graph of a cubic function has two turning points. Obviously, the graph of cubic function has two turning points when x is greater than 0 and when x is lesser than 0 and when x is greater than 4, the gradient of the graph is positive, right? So when x is 0 till 4, the gradient of the graph is positive. When 0 till 4, when the x is lesser than 0, which means this part, and when x is greater than 4, this part, right? And when it is in between, the gradient of the graph is negative, right? So we have the gradient of the graph as negative in between these values, otherwise we have positive values, positive gradient, right? So for this is 0 and let's just suppose this is 4, right? So for the negative gradient, we'll have a negative curve, or let's just simply say this. Then it will move forward, move upwards, and here we have this part right here. So this would be a positive gradient, this would be a positive gradient, this would be a positive gradient. From here on, the gradient would start to decrease, and then decrease again. Here it will be a negative, then we start getting positive over, right? So we have this term. Now moving on, we have question number 26. The graph of this intersects the y-axis at negative 30. Find the value of d. Right? So we have intersects the y-axis, which means x equals to 0, y equals to negative 30. Right? So when x equals to 0, we have negative 3, b, and then 2, and our y is equals to negative 30. Right? So this negative 6 would be divided by negative 30 to get our answer as 5. Right? So our b would be 5. When x is greater than 0, I've simply plugged in x equals to 0 over here. Right? So we have when x is greater than 0, the graph crosses the x-axis once. Write down the coordinates of this point. Right? X-axis once means y is equals to 0. When y is equals to 0 and x is greater than 0, right? For x to be greater than 0, we have x minus 3, x plus 5, and x plus 2. This would give us negative 2, this would give us negative 5, this would give us positive 3, right? So this would be 3 and 0. Moving on, we have question number 27. The diagram shows the speed time graph of the journey of a car. The car starts from rest and accelerates at a uniform rate for 15 seconds before reaching a constant speed of 30 meters per second. Right? Calculate the acceleration. We simply need the gradient. It has reached a speed of 30 in 15 seconds. So this would be 2 meters per second square. Pretty easy one. After t minutes, the total distance traveled is 45 kilometers. Find the value of t. So first we need to calculate it. First we need to convert it into meters. So 45, this would be 45,000 meters. A kilo means 1,000. So this would be multiplied. So this is 45,000 meters after time t, right? So let's just calculate the area of triangle first, and the area of square is added in area of triangle to get the final distance, that is 45,000 meters. Our area of triangle would be 1 over 2. We have our height as 15. Sorry, we have our height as 30 and our base as 15. This is 45,000. And our area of square would vary, but the length is 30, right? So we need to calculate the breadth. This would be cancelled out, so this would be 15. Here we get it as 225, I guess, and this is 30b and 45,000. 45,000 would be subtracted by 225. 45,000 subtracted 225, and then we'll divide it 44775 divided by 30 to get our answer as something like this. Have you made some mistake over here? I guess I think we have made some mistake. After t minutes, okay, t minutes, okay. So we have calculated the seconds. We have to convert it into minutes. This would be divided by 60. 1492.5 would be divided by 60. So we get our answer as 24.875. Right? Have we again made a mistake or so? After t minutes, I guess this would be this, right? So this would be t minus 15. Right? So this would be t minus 15. We have this 225 and 45,000. Since we subtracted it already, so we have 44775, and this would be 30t and minus 15, and this would be added. So this would be 450, I guess, and 450 would be added over here. So we have 4475, 44775. We have to add. We have to add. We have to add 450 over here, and then we have to divide it by 30 first. 45425 divided by 30. Then we have to divide it by 60. 1507.5 divided by 60. Yes, we have our answer, right? So this is our answer. This would be 25.125, right? This is t minus 15 because it starts from here, right? Moving on, we have question number 28 where the table shows some values for this. Complete the table, right? So we'll plug in negative 0.5 over here and over here. So this would be 3 multiplied by 1 over 4, negative 2, and negative 1 over 2, negative 1. So this would be cancelled out. This would be positive 1, and positive 1 and negative 1 would be cancelled out. So we have 3 over 4, that is 0.75, right? And you can simply use this. We'll get the answer as negative 1.25, right? You can simply use the calculator over. On the grid, draw the graph of this for negative 1 till 1.5. At negative 1, we have 4. At negative 0.5, we have 0.75. This is 0.5. This is 0.75. Right? At 0, we have negative 1. At 0.5, we have negative 0.25, 1.25. At 1, we have 0. And at 1.5, we have 2.75. This is 2.5. This is 2.75. Right? So this would be something like this. Right? Since we are told to just complete the graph, this would be something like this, right? By drawing a suitable straight line, solve the equation this, right? So here we have this equation, which is equals to 3x squared plus 2 negative 2x negative 1, and here we have to simply add negative 2x and negative 1, right? So this will be going on the right hand side. This would be 2x plus 1. We have to create a y is equals to 2x plus 1 line. So when x equals to 0, we have y as 1. When x is 0, we have y as 1. When we have x as 1, we have y as 3. Right? So let's just draw the line by joining these 2 points. Here we have a line, and this is the point. This is basically 0.9, 0.8. This is 0.75. Sorry, this won't be 0.75. This is 0.25. But this is 0.25, right? This would be 0.30. This would be 0.35 and 0.40. So this would be 0. Something in between 0.35 and 0.40. You can take it as 0.375, right? So let's just take it 0.375, which is in negative, right? So we have, moving on, we have the question number 29. The distance time graph shows information about Kai's journey from home to the office. Calculate the average speed in kilometers for Kai's journey from home to the office, right? So we started from home, it reached office. which is kilometers, distance in kilometers. So this is 60 kilometers. It has traveled 60 kilometers in a 2 hours time, right? So this would be 30 kilometers per hour speed. It reached in 2 kilometers per hour. Sorry, it has traveled for 65 kilometers to be exact, right? This is 65 kilometers, right? So this would be 32.5. We have part B as when Kai arrives at the office, he finds his meetings is cancelled. He immediately returns home at a constant speed of 50 kilometers per hour. Pretty fast, I guess. Complete the distance time graph to show his journey home. Right? So 65 kilometers traveled at 50 kilometers per hour. So this would be 65 divided by 50. 1.3 hours. There's, 0.3, what is 1.3? 0.3 multiplied by 60. What is this? 0.3 multiplied by 60 would be 18, right? So 1 hour and 18 minutes required. 1 hour, 18 minutes. So this would be 13 and 13 hours. This is 13 hours, 30 minutes, right? And this is 13 hours, 15 minutes. And we have 15, this would be 18, 13 hours, 18 minutes. And it has traveled at a constant speed, I guess. Yes, a constant speed till 0, right? So it comes back again. Just use the scale. Yeah. So this will be a line. This will be our line, right? Now we have the last question, I guess. We have question number 30. The diagram shows speed time graph for 16 seconds of a car journey. Find the deceleration. This means this part. So it has the speed has decreased from 10 to 0. This would be 10, and in 4 seconds. So this would be 10 over 4. Since it's a deceleration, we will not be required to place a negative sign. So this would be 5 over 2. That is 2.5. Right. For the total distance traveled, we'll be calculating the area of trapezium, since it's discussed earlier that the area of speed time graph gives you the total distance, right? So we have our height as 10 and our bases as 16 and 12, right? So we have our height as 10 and our bases as 12 and 16, right? Cancel this out. This would be 28 multiplied by 5, which is equals to 140, right? I guess this was the last question. So this was it from my side. Thank you so much for watching till the end. Please do like, share, and subscribe our channel. Thank you.